alluded to in the introduction, is more on the application security side and the tooling associated with application security. And then Colby is more of a guru within the DevOps world. So we're going to basically give you the information around how security works in a DevOps world. What are the best practices around implementing security? What are the best practices around implementing DevOps? So really can have a holistic approach that is just not DevOps or out-of-band security or application security. It's truly a DevSecOps initiative. I just want to, put a little caveat before I get going. You don't have to agree with everything I say. A lot of the things I say are based on real world experiences I've had, talked to a lot of people around the world, from Australia to Japan to Europe to the US. So it's not really based in fact, it's based in experience. And if you have a different opinion or a different experience, that's great, because a lot of times people come to these type of virtual presentations or even in-person presentations to not only learn from the speaker, but to learn from your peers. And maybe you have some ideas around best practices, but my goal is for you to really take away 1 to 3 things in terms of actionable items or new kind of a lens on something to really help you solve a problem you're facing today. So before I jump into the deck, Colby, is there anything you want to say?
No, I think you got it pretty much covered.
Okay, great. So we're going to start off with basics. And I'm going to pass this to Colby in a second, but whenever you talk about DevOps, you always lead into a presentation with the intersection of development, test, and delivery, and the overlapping nature of the bubbles is what DevOps is. From a conceptual standpoint, DevOps is about processes, connections, automation, but really what the grassroots effort or the foundation of a DevOps program is a lot of the tooling and the processes and the culture associated with the tooling itself. One of the things that we're going to focus on today is the tooling associated with application security and where that slots and fits itself within a DevSecOps initiative. And I'll pass it to Colby to kind of give his take on how these things relate to a true DevOps environment, agnostic to anything security.
I guess it's one of those things where it is like just kind of like a approach of like, it really has to be everyone's involved, and you don't just have like your devs hidden over in the corner and your ops team hidden over in the other corner and no one talks to each other, and then DevSecOps, your security team over in the corner. It's kind of everyone having to balance those things between them.
No, that's great. And Colby, just a question for you. Do you feel that DevOps is totally mature, or do you think it's still evolving, still maturing? I mean, I have my take on this, but from your expertise, do you think that there's better tooling and technologies that are going to come out, or do you feel that we're kind of in a best case scenario based on what we have right now?
Oh, we're still definitely like a long way from a best case scenario. Like I know there's been some really big things come over the, not that many few recent years. Like I know Google put out the big stuff about site reliability engineering and stuff like that. So it's still very much developing.
I agree with you 100%. I feel like we're just touching, dipping our baby toe into the swimming pool of DevOps, and the technologies, processes, and capabilities are going to continue to evolve to make building software more effective based on the needs of customers, program managers, and every other player within the ecosystem of DevOps. So as we move forward, if people are familiar with security technologies, this is not meant to minimize or insult you. The reason why I kind of start this presentation is because a lot of people are familiar with DevOps technologies, but they're not really familiar with application security technologies or the acronyms associated with application security technologies. A past experience I had was speaking at a DevOps conference, and I started with a similar presentation to this, and I think it was like kind of like the initial implementation of this presentation, which has evolved over the years. And I started to talk about application security acronyms, and I got a lot of blank stares and questions about what is SAST, what is DAST. So I kind of do this to level set. So when I mention an acronym as we move through the presentation, it's kind of already defined. Just my style is I'm not a big fan of reading slides to people. I know everybody can read the slides, and I find it very boring when the presenter just reads slides. But really what I wanted to communicate on this, because on the left is the acronym and the actual technology name is on the right, pretty simplistic. But what really is represented here is a more of a modernization with application security. So static analysis has been around a while now, but from a standpoint of how do we actually implement testing of a running application, dynamic application security testing has been around for a while, but based on its true nature, it's very cumbersome and lengthy to implement in a very fluid DevOps process. That's why IAST exists. It's a modernization of existing technology. A web application firewall was or is a box on the wire that's making whitelist, blacklist type of decisions based on network traffic it's seeing, but it's kind of a yes or no type of equation. A more intelligent type of technology that's very similar to interactive application security testing is runtime application self-protection. And then, the whole question of open source package security, as you include that in part of your applications. Some people called it OSA, or open source analysis, to begin with, but the industry as a whole has really kind of decided that software composition analysis is the term that is associated with scanning of open source packages. So just kind of laying a groundwork, a framework or a foundation for discussions. Colby, do you come across these technologies when you're talking about DevOps initiatives at all, or is this kind of out of band for your swim lanes?
I'm definitely nowhere near in the depth of anything that you're working with. There's definitely stuff here that I've played around with. I've definitely had exposure to all of it, but I can't say it's very common that you're somewhere which is using like all of these things all at once. And
I agree with you 100%. This is a Nirvana type situation. If somebody's using every one of these things, it's probably the most secure company in the world. But from a practicality standpoint, number of headcount, time in the day, and overall budget, it's probably not realistic to think that somebody's going to have every one of these technologies. That's why we kind of want to have a best case scenario and really discuss and move into where these technologies really slot themselves in a high level simplistic example of DevOps. So, the DevOps building blocks are really around development, CI, CD, and production. Colby, do you agree with that in your day-to-day? Or do you have other kind of areas you like to kind of focus on as well from a high level?
Yeah.
Okay. No, that's fantastic. And from an implementation of that previous slide, all those security acronyms that look like alphabet soup that, you're like, what do these mean, Matt? Oh my God, you're just boring me to death with all these technologies. This is how they kind of slot themselves. So when you're implementing a DevSecOps program, you need to think about, first of all, integration, which is the hooks in. We're going to basically hook it into the process, and automation is turning on that technology. Well, what technology are you turning on? As we move, I'm not a big proponent with DevOps. I have a better slide that I'm going to show, but this slide kind of works for this presentation, that it looks linear in nature. Well, DevOps is really a cyclical or a constant process, but just to communicate the application security technologies, I find this is a good slide. So in the development arena, you have testing the source code in the developer's native environment. In the CI arena, or CI orchestration level, that's where incremental SAST, again, a modernization of static analysis. It's basically, instead of doing a full code scan every time you're building the product, you're only doing a diff or a scan of the differences that have been changed from one code push to the next, and automating and integrating open source analysis, or as it's commonly called now, software composition analysis. As you move into the CD arena, that's where IAST or the more legacy dynamic application security testing come in, and that's where your consultants would come in with manual pen tests. And then in the production arena, which really isn't my expertise, I kind of stop within the IAST arena or the pen testing arena. That's where web application firewalls occur or implemented, and that's where you would package up an application with runtime application self-protection as well. So this is kind of where the technologies slot themselves when you're talking about specific application security technologies in a DevOps program. Colby, any comments or war stories you want to share?
Yeah, I guess like this kind of thing highlights, if you are trying to implement one of these things, it kind of shows that you do need to have something in place, something can be quite a high level term, but you actually have to have CI in there. You actually have to have CD in there before you can go putting these like automatic analysis things on. And, you know, if you're just wildly pushing everything to production, it's going to be more of a procedure change than just, hey, I added in this cool dynamic analysis testing thing.
You know, absolutely. It's all about, you know, and I think the application security technologies that we're talking about, you know, in the gray here, for application security to be effective, it has to complement DevOps. You can't change DevOps processes to account for security. That's the first no-no in terms of creating an ineffective process, because you don't want out of band, out of sync. You don't want additional requirements. I'm kind of, you know, foreshadowing some things I'm going to talk about in a little bit, but really the gray has to complement the purple, is the way I always look at it. And you can't disrupt DevOps just for security. Security has to fit the processes of DevOps. So as we move forward, one of the things too I like to talk about, and Colby, maybe you have your take on this, is I hear a lot of people use the term Agile. It's very common that I'll have a conversation with somebody and they're like, oh, we're Agile DevOps. And I'm like, what do you mean by that? And they're like, well, we're Agile DevOps. And I'm like, well, are we talking about a noun or are we talking about an adverb? Are we talking about, you know, a software development methodology that exists in your development arena of your DevOps program? Or are you really flexible to change? You can pivot really quick based on customer requirements. And that's where I kind of say is, you know, what do you mean by Agile? If you're talking about the software development methodology, that's something different than being responsive to change. The silly analogy I like to say is, you know, DevOps is an umbrella of many different technologies and disciplines, as we saw. And if you say we're talking about the noun, the software development methodology, it's like saying, you know, Agile DevOps is like engine car. It's like a component of a greater thing. And Agile is if you're talking about the capabilities within the software development methodology, you're a component of a greater thing. Where the flexibility to change is, I think, the common usage of the term Agile. I mean, Colby, in your experience, you know, implementing DevOps programs, do you see more people using it as the methodology noun, or more of the flexibility? Hey, we're responsive to change.
Generally the latter, whereas I feel like it probably should be the former. So I'm not working in like a big, you know, DevOps team, and I'm not following like the strict framework. But you know, I do often see people say that they're agile, and that basically means that they commit all of their code to the master branch.
And there's no right or wrong answer here, but I just like, you know, people get comfortable with, you know, usage of a word, and I just like to say, hey, what are we talking about? Or usage of an acronym or things like that. I always want to kind of dig in and, you know, kind of tweak it a little bit so I understand what path they're going down. And I agree with you. I think, you know, the latter of, you know, being flexible to change is more the norm than the exception. Do you agree with that?
Yeah, I think if someone specifically is talking the framework, they'll kind of go out of their way to say we follow the Agile framework, because the word Agile is, you know, in the same way that the word DevOps is thrown around to mean a bunch of different things.
Totally agree. So just food for thought. Again, just trying to give food for thought. You know, 1 to 3 things is all I'm looking for you to take away today. So maybe this is something you're like, hey, when I say Agile, what am I actually talking about? Maybe that's one of the things. Maybe we just need to hit 2 more. So we'll work through this, and, you know, we'll try and uncover those other 2 as we move through. So CI, I have a silly analogy, Colby, that I like to say with CI, that it's I don't know, maybe it's really dorky, but, you know, CI is the process of building the software. CI orchestration is a common term. It's about pulling all the technologies together in an automated fashion. You know, that could be your build environments, your source code management systems, your binary repository, open source, all those pieces together. So CI is the process of putting it together, and I like to kind of really jump on that orchestration term, where I say CI is kind of like the conductor of the symphony orchestra that's building your code. It points at the wind section, the brass section, the string section to create beautiful music. And that beautiful music is really putting all the pieces of your code together in a consistent, automated, effective process. It's basically the overarching brains of the system to actually build the code. because you're going to have things that are happening to the left of the process, to the right of the process, but it is creating the package, the crown jewels that is then being deployed to your really fancy containers or virtual environments that everybody's talking about today. And Colby, this is your swim lane. I'm getting a little bit out of my swim lane here, so I'm going to pass it off to you to give your take on, what, really continuous integration is all about.
I guess like the way I always like to think about it is I think of what I was like as a new grad. And, if you imagine getting a new grad into your team and you say, hey, go and contribute to this project. If you think of yourself as a new grad and that being a really daunting task and not really knowing if you're doing the right thing, it might kind of highlight the fact that maybe you need to do some improvements with your CI pipeline, because getting some of that automatic feedback of, just basic stuff of just saying, yes, this is following at your style guide, and no, we haven't found any like glaring issues with the code. That's the kind of thing that can be automatically passed back to, like an intern or a new grad, and kind of give them the confidence to go and write code instead of popping over your shoulder every 5 minutes going, did I do the right thing?
Totally get you. Totally get you. So, I mean, but do you, I really feel that CI is really the center of the DevOps universe. Do you agree with that? Or, I like to learn from somebody like you too, to kind of validate what I say. Do you feel that CI is kind of the center of the CI universe, or do you feel that it's equally distributed throughout all the processes within DevOps?
I mean, really, you just want it to be part of everything. Like CI and CD together is really what separates, just developer from DevOps in my kind of experience.
Gotcha.
Thinking that just making sure that whatever code you're writing, you're confident that it can go to production and it's just going to be smooth sailing, because when you're the ops side of things, you're the one that has to answer to it if something goes wrong.
No, that's great information. So, you just mentioned it. It's a great lead-in. We didn't even practice this. So what is CD all about? So I'm not going to give the definition, because I feel there's two definitions for CD. And this is a really boring slide. I got to work on this slide. People are falling asleep looking at white background on black text, really boring. But there's two words that are highlighted on this screen. And the reason why they're highlighted is I feel that they are the key aspects associated with CD. It's automating and continuous. It's the delivery of the finished product for testing, for deployment, for many different facilities or actions about getting it into where it needs to be. So, I mean, from my standpoint, I focus on the automate and continuous, because there's really not a lot of application security technologies that I focus on, rather than interactive application security testing or dynamic application security testing. Those are more testing the running application, but the deployment, and we're talking about cloud native environments and microservices and all these type of things. I mean, Colby, and I'm gonna basically jump ahead just before you say that, because I know where you're gonna go, and I'm defining at this point. So I really feel there's two definitions: continuous delivery, continuous deployment. Most organizations are kind of in a continuous delivery environment, where the goal, nirvana, may never happen as a continuous deployment environment. And Colby, I'll let you, give your take on this, because again, this is not my area of expertise, but I think it definitely is something that you have a lot to say on.
I guess, when you say the step of deploying to production, is that a manual step or an automatic step? That's not really like a black and white thing.
I agree. I agree.
Yeah.
So I only have one slide to communicate it, so I couldn't really go that far. So.
So yeah, are you this super fully automated, running all these automatic tests after you merge a branch in Git, which then does a build and pushes straight to production, all automatic, completely hands off? Or is it, I don't expect that you're manually writing config lines on the production server, because you're always going to stuff something up. My first kind of sysadmin role, you weren't like a real sysadmin unless you had broken a tier 1 service at least once. and you get to know it really well when you do that.
I got some slides that are associated with the building of the software to talk to that too in a second. Some humor, so it's not a boring presentation, but keep going, Colby.
But yeah, it was just like so many things is what could you possibly do wrong, and it will eventually go wrong. Because, you know, a lot of the times you're pushing out like a big production change, it might be late at night or super early in the morning to try to avoid like your main business hours. And you'd be surprised just like how many things you can get wrong just by typing in the wrong thing when you're sleepy. And just even if it is a manual process, as long as like it's a strong process where if you put in a typo, it's not going to break your entire infrastructure.
Yep.
Like, yeah, how many, like, I know AWS put out like big incident reports whenever there's like a big thing that goes down. Like, I think it was like last year, maybe like S3, all of S3, I think globally went down for a while, and it all tied back to someone accidentally typing the wrong command.
Scary stuff. I mean, definitely scary stuff. And, you know, that isn't it just inconvenient that, you know, when you're tired late at night or early in the morning, that's when you're going to write the, you know, have the command line open and make sure that everything is perfect and you don't have a, you know, a semicolon versus a colon or something like that. You know, just giving an example of, you know, two keys that look very similar to each other. So I'm a big proponent, and this is kind of talking about the whole DevOps process, is people talk about DevOps and shifting left in DevOps. I don't think there is a left anymore. I don't think there's a right. I think there's the process. What DevOps really produces is a living, breathing organism that's constantly evolving. So the further right, the further left, you need to implement security checks because there's, again, different technologies that find different things during different stages of DevOps. And it's really, really, I think, ineffective to think there's one type of application security test to make sure an application is secure. Because there's different vulnerabilities in code, there's different vulnerabilities at runtime, there's different vulnerabilities in a, you know, a cloud environment versus a physical server environment. You need to be cognizant of all these permutations within your environment. That's why I really like this as a representation of DevOps. So I work with organizations that are releasing software hundreds, if not sometimes thousands of times a day. So to think that there's a linear process, and, you know, that previous slide looked like there was a beginning and an end, and it, you know, it's like a sentence. It started with a capital, ended with a period, and you release software. Okay, we're done. I'm moving on to a new piece of application. Really, this infinity loop of this bow tie, something is happening at every stage, at every time of the day, because the processes tend to be very fluid. I mean, if you're doing 10 releases a day or 100 releases a day, it's still very fluid. The outside kind of, you know, wording and logos are all associated with building the software. So in the code environment, that's where you have your IDEs, your native environments for the development staff of Visual Studio, Eclipse, IntelliJ. You know, you have your source code management systems like TFS, Subversion, Perforce, Git, and all Git permutations, the command line. And then you have your build environment, which is controlled by your CI orchestration layer, you know, TeamCity, Bamboo, Jenkins, Visual Studio. The one that doesn't look as interesting here is testing QA is Jira. So I find that for application security technologies to work in a DevOps environment, they have to complement the existing process. And I find the best way to remediate vulnerabilities is to follow the process that is known. Why do we need to reinvent the process to account for security? Security is a big, scary word, and people always think this is a different process, an out-of-band process because it's security. My feeling is a bug is a bug is a bug. Let's leverage the tried and true associated with functional issues, configuration issues, infrastructure issues that follow a path of known. So let's basically follow that same path of known for the identified security vulnerabilities by static analysis, software composition analysis, interactive application security testing, dynamic analysis, so on and so forth. Colby, you probably have some better slides that depict a DevOps, you know, graphic. But, you know, do you agree that typically there's something happening at every stage of DevOps at all times, or is that more, you know, kind of the goal of a program in the future?
I definitely don't have like a good slide to represent anything like this.
So my slide's good? You agree my slide's okay?
I
Thank
think
you.
it's a
Okay,
very
I
good
feel better now.
representation. Yeah, it really does like properly highlight everything, and you know you're showing like a bunch of different technologies at every step of kind of where it ties into stuff. And you know you may have like your team of, sometimes you find that you know not everyone's using the same IDE and stuff like that as well. So it can like the more different things that other people are using can kind of make this loop kind of become a little bit wonky based off each person. But ideally, like, you know, if you're working with Visual Studio, everyone on your team is working with Visual Studio, and, you know, you can make that nicely integrate with Git and stuff like that. Just trying to make it as streamlined as possible, I guess.
No, that's fantastic. And I mean, again, this is not representative of every technology associated with DevOps or every specific stage of DevOps. You know, it's really impossible to create or include all those technologies or all those processes for every organization on one slide. This is just meant to kind of communicate the different stages. But Colby, I'm gonna ask you a question, because I mentioned before that in application security, the really hot phrase is shift left. We're going to shift security left. Application security is going to shift left. And I'm not picking on you, because I do this live with audiences all over the world. And I say, how many people have heard of shift left? And everyone raises their hand. How many people think shift left is important? And everyone raises their hand. And I like to then say, okay, where is left on this graphic? And people want to have a knockdown, drag out fight. That it's at the design phase, it's at the code phase. And I'm like, there's arrows. Everything is building off each other. I talk a lot of, you know, C-level executives and heads of companies all over the world. And I say, you know, and even from the grassroots engineering side, how many times do you start an application from scratch these days? You know, it's like, I'm going to sit down and write a brand new web app, mobile app, fat client, thin client, whatever client, you know, skinny client, whatever it is. Usually software is developed as an extension, a copy, a branch of an existing code base. So to say you need to start at the beginning or you need to start at the left is kind of like a false sense of security. You need to complement the process and be part of the process, because the process is ongoing. And as I said, in, you know, cloud native type applications, all these things are happening very fluidly, and they're all being put together, you know, within your container environment. You need to be cognizant of all these different permutations at all times. Did I say anything wrong, or do you agree with anything? Or Colby, please disagree with me.
Yeah.
I'm way too.
I totally get where you're coming from. I think I would be one of those people that would argue the design phase is the leftmost part. The main reason I would say that is sometimes you'll definitely like have people sit in the design phase, you know, I guess go into code, that they're going through making everything, you know, that like a little project or a feature or something like that, but they'll kind of stretch those steps for as long as possible and then just go check and build, deploy.
Gotcha.
So I guess when I hear shift left, I think it's almost like the person themselves coming right, of making sure that all of your changes are as small as possible, increments as possible, and get as many things going through the pipeline as possible, instead of building up like a really big chunk of work and slowly stepping through all of the processes.
No, great information. And I agree with you. I mean, there is no right or wrong answer. That's why I like to kind of, you know, query the audience and get your take on things. So thank you for that. I appreciate it. And didn't mean to put you on the spot there. That was kind of a curveball for you. So when I talk about different technologies, these are, you know, I work for Checkmarx, so we have technologies in all these different types of area. This isn't an ad for Checkmarx, but you really need to be holistic in your approach to test at every phase, because there's different types of vulnerabilities that propagate themselves at different phases, from open source to the static analysis, vulnerabilities at the code level, to a running application. So, okay, great. We've integrated automated application security across the board, best of breed, bleeding edge technologies. Every time there's a security issue, I want to break the bill. Colby, that sound like a good idea to you?
I I can see where you're going with this, and it's going to be security shouldn't be stopping people from doing their job, I guess.
That's exactly where I'm going. That again, application security needs to complement the process, and you can't be the boy who cried wolf. You can't, try and kill a fly with a sledgehammer. You need to be very cognizant that the process needs to stay on task. And there's different ways of flagging differences in terms of security risk. There's marking builds as unstable based on security risk, because I'm going to let you guys in on a little secret this evening. There's no such thing as 100% secured application. There's always going to be risk, and that risk is really quantified through really two variables: impact and likelihood. The impact is really bad, the likelihood is really, really high. Okay, you got to fix that. Okay, maybe we break the build for that. But the impact is really, really bad, but it's 0.0000 times 10% that somebody's ever going to execute this. Okay, maybe we have some runway to fix that. So there's always that delicate balance of risk acceptance and that impact and likelihood. And don't be a overly noisy application security professional that breaks the build or insists on builds being broken, because you're never going to get something accomplished. And here's where my color comes in. I'm going to break that one and skip that one. So I was a software engineer for many years, way back, and I broke the build just like, Colby, you said, if you're in the CD arena and you break the release, you're not really truly a DevOps professional until you break something. Well, if you break the build associated with code, you got to fix it too. So, and especially in a DevOps world, breaking the build can be multiple roles within the organization. Just want to, put this public disclaimer. There may be some colorful words in here, but just some interesting memes that I've found out there over the years associated with breaking the build. Colby, you ever seen any of these, or?
Yeah, I definitely have. And it kind of shows that, you never want like your master production build to ever break. But you always want people to be able to test things as near to production as possible before that goes into that production stage. So, I've definitely worked with things where you will do a bunch of work and you won't know it will break it right until it goes into production. And, if ever you've worked somewhere where someone said, no, I don't want to deploy that because it's not working yet, or, oh, I haven't put my code in Git because it's not perfect yet. You really don't want to like freak people out and stop them from pushing stuff or writing stuff. If you break a build, it should be a good thing and it should be encouraged as long as it's in your development branch.
No, I agree. We used to have it was a much crueler world when I was developing software, and we used to, if you broke the build, you were the beanie weenie. So you actually had to wear the little hat with the propeller on it until you actually fixed the build. So it was a much crueler world back then. You were the one with the beanie weenie. So as we go forward, so we've talked about the technologies, the processes, but from an application security standpoint, you could integrate and automate the best application security technologies, but then fill it up with mud. What do I mean by that? So the security policy, or the IP that's actually identifying risk, is really the key to the success of the program. So if you have a security policy that looks for way too much or completely the wrong things, it doesn't matter if you have a Ferrari, if you put mud in the gas tank, it's not going to go anywhere. So the security policy has to be on point to the risk you're looking to remediate. There's always the question, the elephant in the room of this term, false positives. Oh, you find too much stuff. These aren't real vulnerabilities. See, I disagree. I think there's risk involved, but they don't fit your risk profile. So there's a lot of subjective conversation. Why don't we be more specific and really create a policy for new code, legacy code, open source, and anything that you want in terms of a tiered structure, and be very specific. I find when you automate application security technologies, especially at the static analysis level, the best way to start is very, very simplistic. 5 to 10 key things or high risk things in the code that you can't live with. And then once you feel you have a baseline in an application, you turn up the dials over time. I just find that more effective because you're not overloading the process with a lot of subjective conversation. You're specifically focusing the limited resources you have and the time in the day for remediation on the things that you care about most as an application security professional. I mean, Colby, have you ever had an experience with somebody implementing application security and it's been like, oh my God, you just found so much stuff, we just totally bogged down the whole process? Or, you know, any examples where a policy was like way out of whack that really derailed the DevOps flow?
I would be very surprised if anyone's ever gone and turned on something like this and it wasn't immediately all these things are bad, big handbrake. And you know, that's why whenever, if you say to developers like, hey, let's turn on like an automatic static code analysis, or like just even something like linting for syntax checking and stuff like that, they'll go, oh
Yep.
no, I don't want to spend the next 7 weeks like going through fixing everything. So what I always do is whenever I turn something like that on, is you get the big initial like, here's all the big things that it cares about, and maybe you write that down somewhere, but then you turn off like, you know, 90% of those rules, or maybe you only care about new code that's written but not old code, and just say, okay, let's do this incrementally, let's only check these things for now, or let's only check the new code as it comes in. Don't freak out about having this big legacy project where you have to retroactively go back and fix every line of code.
Yeah, I think, you know, taking a stepped approach, and that's one of the things. The power of automation is fantastic, but it's also incredibly scary. And I think that goes in with just all of a sudden, you know, bogging down with too much information and then scaring the development staff, scaring the DevOps architects, everybody. So, you know, you have to tread lightly as an AppSec professional in an automated process associated with your technologies you're looking to be implemented as part of DevOps. So, and this is kind of, we're getting close to the end here, you know, where does security clash with key DevOps requirements? The two areas are really speed and stability. So speed is associated with full code scans taking way too long. You know, we used to have a very structured software development process that gave you tons of time to test things and much more plotting in terms of its release cycle. Well, waiting days for a dynamic scan to complete, or, you know, 20 hours for a static code scan to complete is really too long, and it really deviates from the success of DevOps. That's why we've seen modernization in the application security technologies, where instead of just having full static code scans, we have incremental static code scans. Instead of having DAST scanning of an application that has to crawl every level, let's leverage the existing functional testing with interactive application security testing. The other kind of caveat is things that are out of band or out of process. You know, special requirements for a security scan or a security build. That's going to delay the process and cause a lot of headaches. Security really should be transparent to the process and just be initiated by certain activities within the process. And the stability aspect, I kind of touched on this and beat it to a pulp already, is that don't be too noisy. Don't break builds for security risk unless it's something that you can't live with, you know, at all. I mean, you have to be very pointed in breaking a build for a security risk, because there are ways to actually make people aware and start that remediation process without having to slow the train down completely or stop it completely to account for security. I mean, Colby, agree, disagree? Any feedback you have in those areas?
Yeah, whenever you put something like this in, it's, no matter how well you tune it or tailor it or anything like that, it's always going to make things slower. But hopefully that should only be short-term, you know, loss for a long-term gain. Like if you're forcing,
you got to break some eggs to make an omelet.
Yeah, like when you first change any process, even if it's better, it's still gonna really throw people for a loop sometimes. Like, you know, what do you mean this is SQL injectable? But, you know, hopefully if people are writing insecure code, it is going to save you a whole bunch of time and heartache in kind of the long term.
No, I agree. So yeah, plan accordingly, but don't be overly noisy. Complement and be pragmatic, or practical, I should say, about implementing security technologies, because you only have one chance to make a first impression. So in summary, I really wanted to say thank you for everybody. I'll let Colby wrap up, but I really feel that you need to have an effective program by having a effective gas for your program, and that is the security policy itself, and really implement something that you care about and only the things you care about in terms of identification to drive remediation. Because one of the biggest mistakes is really bogging down the process, which is finding way too many things that it's, kind of illogical to think that it can be fixed in a 1 week period of time or a 1 day period of time. Security has to be everywhere, left, middle, right, and everywhere in between, because there's different types of vulnerabilities that can be found at different stages of the DevOps process. And really, if you're not doing anything for open source at this point, really think about an open source policy and provide open source scanning, both at the static and at the component level, because a lot of the vulnerabilities you're hearing about all over the world have an open source aspect to that breach. Stay ahead of the curve and don't just think about your homegrown or third-party developed code, but make sure you're addressing the risks associated with open source. And Colby, I took the lead here, and you were fantastic and a good sport when I tried to put you on the spot. But any comments as we wrap up?
I mean, I guess you only have to install one NPM package to see how many dependencies is floating around out there. And
oh yeah, inheritance is no joke.
Yeah, and I think when you think about it from the perspective of some people do get quite scared of reporting vulnerabilities all the time and trying to chase them up because no one wants to look bad. But I guess if you looked at it from the other perspective of if every single month you wrote a report saying we have found no vulnerabilities in all of our services, and you hand that piece of paper to your boss, that's going to make you look far worse than if you said we found all these vulnerabilities and we've actually gone ahead and fixed them. And I guess some of the biggest problems of when I've seen people implement stuff like this is if things aren't going into Git, or maybe your process isn't integrated with your IDE, then it's just not going to happen. I've worked with so many people across the years where they will be too scared or intimidated to commit code up to Git or whatever version control you're using, because they don't want to write bad code and they're worried that their code is vulnerable. So they say, no, I'm just going to write it locally and I'm not going to commit it until it's perfect. But if you do have like a process where they can commit to their own branch and Jenkins will go through and check all of this stuff for them, then hopefully you can get over the anxiety of committing for people and actually force them to say, no, commit all of your code all the time. And when something does break or is something highlighted as insecure, kind of encourage it and go, yes, you wrote insecure code. Let's go and see why it's insecure. Teach you, no one's going around hitting you on the back of the head saying, you didn't check this for CSRF protection. People are going, cool. Let's, it's cool that we have a cool learning experience to teach you about this stuff, because, no one comes out of uni knowing how to write good code.
Well, it's kind of a Pandora's box too, because a lot of the most complicated vulnerabilities from an application security code standpoint have a data flow or a control flow associated with it, which may scan multiple developers' environments. Like, if you're thinking tiered architecture, a developer for the UI tier, the business logic tier, the database tier, whatever tier you're talking about, it's not really a vulnerability to all their code in that data flow that source to sink is actually completed. So that's one of the things that I find very interesting, that organizations say, I want to know, who needs the most training, who's the worst developer. I'm like, you can't really decide that, because these data flows can be 20, 30 steps in code and cross hundreds of developers, and it's not really made apparent until you bring it all together and scan it and map it and say, hey, look, there's a data flow here that has no sanitization. Who's responsible for the sanitization? Is it the UI tier, the database tier? So, I think that's one of the things that people are always afraid of their code, but I think it's the whole complexity of the software itself that really is the propagator of risk and vulnerabilities. And that's why, you know, you have to work as a team and not worry about your little piece of code. I think that it would be really helpful for people to understand that it's the whole application that could potentially be risky, and it's not one person's fault. It's, you know, it's a village. You got to work together as a village, just like, you know, kind of DevOps and community and processes. You got to work together as a village to make sure applications are secure. Agree with that, Colby, or
yeah, like,
step on your toes?
It is about resourcing. You know, KPI can be there for your benefit, not to, you know, push everyone like a slave driver. You know, if things are going really wrong in your pipeline, like you're getting lots of failed builds all of the time, then that's, you know, hopefully if you have like a good management structure, they'll take that and go, we need to focus more on, you know, training or this delivery, you know, process and stuff like that, instead of just whipping people saying, write good code. I think you're muted.
I just want to say thank you, everybody. Sorry, I was on mute. That was the first time I did it, and it was right at the end. Dang it, I can't believe I did that. But thanks, everybody. Hopefully you got there 1 to 3, hopefully more on the side of 3 than 1, you know, takeaways from my talk. And Colby, I'll let you wrap on your side.
Yeah, I guess just make sure that you have a good process in it. If you're adding in automated steps to do code analysis or other things like that, it really should complement it instead of being like this big jarring thing that gets in the way.
All right, thank you. You know, Mike, are we going to open it up for questions, or are we up against time? I kind of lost track of time. We were having, you know, Colby and I were having so much fun.
I could tell you guys were having so much fun. I didn't want to interrupt. So we are going to throw open to questions now. I think everyone's used to the technology now. Everyone knows Zoom, use the question and answer box. Just while you're all sort of thinking of your questions, I'll just do a little bit of quick housekeeping. We were, of course, recording this. So we will make this available on our YouTube channel. We've got Laura, who is our wonderful media and comms person, who's organising all of that. Just another quick comment, I suppose. If one of our anonymous attendees is right, apparently, Matt, you are very much similar to Bill Burr, who is, of course, a comedian over in the States. So I'm guessing that's a compliment. I think I only know him from Breaking Bad. So
any press is good press. So I'll take it.
Awesome. So yeah, we'll go to questions shortly. But if I could throw just one little thing in here, and you know, look, for those that know me, I'm AusCERT Senior Manager. So that means that I'm, you know, I do more things like this nowadays than I do on the tools, actually writing code. I mean, I think Colby would be horrified if he thought that I had access to any of our repositories or anything. I just wanted to suggest, though, that, you know, we've had quite a number of participants on the call. I think it peaked at about 96 or 98. Out of all of those, there's bound to be some management watching, maybe C-levels, senior management. If there's one thing that you can take away from this presentation, it's a great step that you've actually come to this and watched something that is perhaps a little out of your comfort zone if you are management. But you've actually just seen a little bit of an insight, I suppose, into what the real process is that should be going on inside your teams. Now, unless you get amongst your team and learn, you know, well, what are they doing? What are their barriers? Why can't they do continuous development or ensure that security is being considered at all stages of the life cycle? You'd be surprised what you'll find out just by talking to them. Operating in silos is obviously, you know, one of the biggest problems that I've seen in my career in many different jobs. And you as management are responsible for that. So if I could just, I mean, hopefully we've done that right here. Colby, you don't have to say yes or no. But if I could just suggest that everybody else maybe take that away and break down some of those barriers to get some of this good stuff working. So shall we go to questions? We've got one right here from Mark. Any comments around small teams that do most of the DevSecOps themselves in addition to development? That sounds very close to home here, actually. Who wants to take that one?
Sure. I mean, I can give my take, and then Colby, why don't you give your take?
Yeah.
So, you know, for DevSecOps, don't think of it as having to be a huge program. We actually have released a new capability that can basically automate the scanning of your source code based on push-pull requests from source code management that really make it effective, where you don't have to go through Herculean efforts to set up a very robust or complicated CI process. You know, you could basically have more of a basic process, but still have automated application security scanning based on webhooks that listen for commits of code by the development staff. So I really specialize when I work with customers of any size through a solution architecture process to understand how you develop code. Doesn't matter if you're 100,000 people or 10 people, there is a process that can work for you in a very effective way. And don't think that you have to, be a huge company with thousands of developers to have automated application security testing. Colby, that's just my take on that.
I guess what I would say is, I've always been part of like a really small team, and, going out of your way to do all these extra things can be really complicated. But I would wager if you're in a small team, you probably have most of your technologies all using the same kind of, backend. Like, we use Python for most of the stuff that I do. So I know if I can take an approach of something generic, which covers, the majority of stuff, like just, even if it's something really simple, like, you could argue this isn't really security, but just Python syntax checking, put that on automated builds for all of your repos that have Python, and just see how that works with your process, so that obviously when you turn it on, everything's going to be red, because it's going to be some thing that you'll disagree with the linter about. Like, no, I should be able to have more than 80 characters width. Screens are bigger these days. But see how that kind of works in your process first. So if you find that starts getting really, really annoying, or people are committing stuff and it's breaking it, but still pushing it anyway, you kind of need to solve that before you start turning on static code analysis. But then, once you do go down paths like that, just try to make it as generic as possible, because you can't have like a super specialized solution for every single one of your web apps when you're like this tiny team. Like, I don't have time to set up like, front end user automatic testing with Selenium or anything like that. Because, I'm basically in a team of 4. And yeah, I would just say like process first, technology second.
Great. Thanks, Matt and Colby. Now, do we have any other questions? There's nothing popping up in the Q&A right at this minute. So being the very chatty person I am, I'm going to start asking questions, because this has been very interesting and entertaining for me. So if those listening would like me to stop talking, you're going to have to ask some questions in the Q&A panel. I have my own opinions on what I'm going to ask both of you. But I'm really, really interested, particularly after everything we've heard today, I'm interested to know what you think about why we're still having security issues in applications and software today. It's a can of worms. I'm opening it, but let's do it. Your take, Matt and Colby. Who'd like to go first? Matt? You're muted, by the way.
Colby, you can go first this time.
I mean, it's always going to be an issue, at least for a very long time. It really just does come down to the trade-off of, how agile do you want to be? At the end of the day, if something's very, very urgent and you push something out and you see it breaks your automated tests and you go, oh, whatever, that test is wrong, just push it to production, this is really, really urgent, you're still going to skip past that stuff. And, I have had that exact situation where a code deploy has broken something and I've needed to push out a fix really quickly, and it broke my build, and I went, oh no, that test is wrong, don't worry about that. And I pushed that straight to production, and the test was right. And I you know, took out all of the Wi-Fi for UQ when I was working there. So it's always going to be an issue. Like, you know, we're not going to turn around and write everything in Rust starting tomorrow. We just don't have time. And even if we did, it's not going to be magically perfect.
No, I agree. I'm going to look at it from a little different approach, where I feel that the biggest problem is the modernization of code and just the sheer complexity of applications. You know, it's very typical for applications to be millions of lines of code these days. And, you know, there's not really one person that understands every aspect of those multi-million line of code applications. So there's a lot of places that misconfigurations, you know, not proper validation of data is really occurring. Cloud native, where something's really not brought together until it's in a production environment. So it's really about the understanding the complexity of an application, the flow of data. And I think that's what really continues to provide, you know, hackers or nefarious people opportunity, is that the people that are writing the applications have a set period of time, and it's very difficult to understand every aspect, you know, every data flow, every entry point, every execution point, every exit point within your software. And I think that's why there's always opportunity. And I don't think we'll ever understand it from a holistic nature, because, you know, every time you write a new line of code, the whole infrastructure or the whole threat landscape is changing.
Indeed. And carrying on from that, Matt, that's one of our attendees, Bradley, has just mentioned something that reminded me of probably the first thing I ever learned from my mentor 22 years ago. I can't remember when it was, a long time ago now, when I was first in the InfoSec field, back when it was called InfoSec instead of cybersecurity. And he taught me the attackers have to only think of one way to get in, whereas you've got to think of every single way they could get in and plug it. And that's stuck with me ever since then. Many things that my mentor taught me have stuck with me, but that's the one that's really, really ringing home through everything that you guys have said today, that the complexity of code has just gone crazy. And there's too many ways that attackers can exploit it. So I hope everyone's taken something away from this that they can usefully implement in their own workplace. We really, really want to thank Matt for attending and presenting today, I should say, and Colby for presenting. It's a pleasure to work with Colby, but actually having this platform where he can share his talents with the rest of the world is wonderful. And Matt, we do appreciate you. Obviously, we're on a different time zone, so thank you very much for sharing your expertise with us on this webinar. So we're going to wrap up now because we have run out of time. But as mentioned before, this will be on YouTube. So please share it with your teams, and hopefully we can teach the world a few things or two. So thank you, everybody. Thank you to all our attendees. As I said, we had up to 96, I think was our peak, and we averaged around 90, and it's just during the Q&A now that some have dropped off. So thank you very much, everybody, and we'll wrap it up there.